Hi, my name is Chenge, and I'm a PhD student in the Department of Life, Health and Chemical Sciences at the Open University. My PhD work is quite exciting. It's bringing together different disciplines to try and solve a global health problem. This global health problem is Candida auris, which is a new species of Candida that was first discovered in Japan in 2009, but has since spread across the world, with cases on every continent. My project brings together aspects of microbiology, public health, and chemistry. The chemistry part is linked to drug discovery. The aim of my project is to find new treatments for Candida auris infections and also find new ways to prevent the spread of Candida auris through chemical disinfection. So when we talk about managing infections, there are two arms that work hand in hand together. One is preventing the person from getting the infection, and the other is treating once the infection has become established. In prevention, we're looking at things like chemical disinfection to get rid of the fungi or the bacteria in the environment, and on the skin of patients and from the body of the patient. And then in terms of treatment, we're now looking at therapies that can be used to kill or get rid of any bugs that will have infected the person. What happens when these pathogens become drug resistant is that it becomes more difficult to treat the patient. So there's a whole world of science that's devoted to preventing the spread of antimicrobial resistance and also finding novel compounds to treat them. So this is a very important application of chemistry. So there are different approaches to drug discovery. One is where you have a library of compounds that is being generated by a chemist, and you get access to that library of compounds and you test each and every compound in the library for any potential drug activity. Another approach is to look for non-purified compounds that could exist. So for instance, one project that I've been involved in is looking at plant extracts, where you get the leaves of a plant or you get a lichen, you extract everything that's in that crude solution from that plant or from that lichen, and then you test that against fungi or against bacteria and see where there's activity. Where we've found activity, we then go to the chemist and we say, we have this concoction, if I could put it that way, and we want to see what's in it and what could be potentially interesting for drug development. And they will purify and analyze the different chemicals that are in that mixture. And from that process, we can start to narrow down which specific compound might be having an effect. And yeah, that's always an exciting thing because you can discover new things that have never been discovered before. The coolest part of my project is that I get to do something I've never done before. I get to work with the Drosophila fly model in order to test the toxicity of the drugs as well as their efficacy against the fungi. So essentially what this means is we use the fly model as a replacement for animal studies. We expose the fly to the drug and we see whether or not the fly can tolerate the drug. And then we also infect the flies with the fungi and try to treat them with the drug and see whether our drug is effective at killing the fungi living inside of the fly. The reason why we use flies is because they're small, they're easy to work with, they allow us to avoid using mice and rabbits, and also, amazingly, they have a very similar genetic system to ours, so their immune system is quite similar to mammals as well, which I found really, really fascinating when I started working with them. So that's definitely one of the coolest parts of my project. The long-term impact of my research project could be the discovery of novel natural sources of antifungal drugs, as well as giving us further understanding of this pathogen that I'm working on, understanding how to prevent it, how to clean and disinfect for it, as well as how to treat it. If I had to give advice to potential students, I would say be open-minded. Keep an open mind to different opportunities that come up. When I started out, I had a very clear idea of exactly what I wanted to do. And what I'm doing now is a bit different, but it brings together different aspects of science. And I get to collaborate with chemists, I get to collaborate with public health specialists. And that's only because I've ended up here at the OU doing an interdisciplinary project. So don't think of science as one discipline. It's all very interdisciplinary and there's always room for collaboration.